Two hulls side by side, connected by a deck stretched between them like a bridge. That's a catamaran, and there's real engineering substance behind why it's built this way. In this video, we're going to break down how those twin hulls can make a ship incredibly fast and stable, where that same design starts working against you, why everything from high-speed ferries to modern warships use it, and how it stacks up against the traditional monohull and more complex multi-hulls like trimarans. By the end, you'll know exactly when a catamaran is the smartest choice and when it isn't. Speed, comfort, efficiency, and capacity. Ships are always a game of trade-offs, and a traditional monohull strikes a balance between all of these. The catamaran takes a different approach. Take the HSC Francisco, for example, a high-speed ferry running between Argentina and Uruguay. It's widely regarded as the fastest passenger catamaran in service, reaching speeds of around 58 knots. For comparison, most large monohulls rarely push past 30 knots, and even many military vessels top out at around 35 knots in operational conditions. And Francisco here is carrying hundreds of passengers and cars. So, what's the secret? A long, slender hull slices through the water with far less resistance than a wide one. The thinner it is, the smaller the waves it creates, and the faster it can move for the same power. Fast vessels, from naval destroyers to racing yachts, use long, narrow hulls for this exact reason. But there's a limit to how fast you can go. It's called hull speed, the point where the ship starts climbing its own bow wave, and resistance skyrockets. The formula ties directly to waterline length. As we've said, longer ships can go faster than shorter ships before hitting this wall. Now for catamarans. Each hull is so slender that they create smaller waves and don't get trapped climbing them the way a wider monohull does. But make that single hull too thin and you run into problems. There's barely any deck space and stability drops. Efficient, yes, but not practical for carrying people or cargo. Two slender hulls, spaced apart and joined by a deck. You get the speed of narrow hulls with the stability and deck space of a much wider vessel. The combination of efficiency and balance is what makes the catamarans like Francisco stand out among the fastest ships ever built. Its twin hulls don't just help it slice through the water, they also keep the ferry from rolling the way a similar monohull would. For passengers, that's what really matters. There's not much point arriving early if you've spent the whole trip fighting seasickness. So what actually gives catamarans that planted, steady feel? A lot of it comes down to the shape of the water plane, the outline where the hull meets the sea, and two things naval architects watch closely: the righting lever, GZ, and the metacentric height, GM. When a wave tips the ship, the center of buoyancy slides toward the low side. The farther it moves away from the ship's center of gravity, the longer that righting lever becomes. Multiply that lever by the ship's weight and you get the righting moment, the turning effect that tries to push the vessel upright again. A catamaran's wide stance makes that lever longer almost by default. When it heels, the center of buoyancy shifts sideways toward the lower hull. And because the hulls are far apart, that shift is much bigger than on a monohull. That produces a big GZ, and at small heel angles, a large GM. In simple terms, the ship's weight now has a longer arm to work with, so it pushes harder to stand the vessel back up. That's why catamarans feel so stiff in roll. They don't lean very far before that restoring force kicks in. There's one more thing about stability worth noting though. While catamarans resist rolling side to side beautifully, they can be more prone to pitching, that bow up, bow down motion in head seas. The same long, narrow hulls that give them speed also means less buoyancy reserve forward. Another advantage of the twin hull layout is shallow draft. By Archimedes' principle, a floating vessel must displace its own weight in water. The heavier the hull, the deeper it must sit to balance the weight. A monohull, with all its weight concentrated in a single broad hull, needs to sit deeper in the water to achieve that same buoyant force. A catamaran spreads its weight across two slender hulls. Each hull displaces less water, but together they provide the same buoyant force while keeping the vessel higher on the surface. That lets it slip into ports and anchorages that deeper ships can't touch, valuable for ferries, patrol craft, and leisure boats working close to the shore. So far, we believe we have proven why this vessel should be the best and standard design for all ships. Fast, stable, and spacious. But like every design, those strengths come with compromises. In rough seas, waves slam into the underside of that connecting deck with real force. The impact is loud, jarring. It's called wet deck slamming, and passengers absolutely feel it. Designers shape hulls with deeper V sections, raise the bridge deck, and add deflectors to push water sideways. But you can't eliminate it entirely. There's also the problem of torsional loads. That gap between the hulls needs a very strong bridge deck, because waves don't hit both hulls the same way. One hull can be on a crest, the other down in a trough, so the whole structure tries to twist. Engineers designed for that by turning the bridge deck into a huge torsion box. In simple physics terms, the twisting moment is the wave force multiplied by the distance between the hulls. So, a catamaran's wide deck gives it a big lever arm. To keep that twist small, the structure's torsional stiffness has to go up, which means deeper girders, thicker plating, and more internal framing than a single hull deck would ever need. But that brings extra complexity, cost, and more weight than it looks. All of that is additional steel or aluminium before you even count the second hull. You're basically building two ships and connecting them, so a catamaran can end up with around 15 to 20% more structure than an equivalent monohull. That structural penalty eats into payload, and you still have to pay for it in construction. Maneuvering this thing is as crazy as it looks. With engines or jets spaced wide apart, a catamaran can pivot almost on the spot by running one engine forward, the other in reverse. Excellent for tight harbours. But further offshore, it's different. With less hull area in the water and lighter displacement, catamarans can be more sensitive to wind and waves when turning. A monohull's deeper hull and heavier displacement makes it feel more predictable and steady in open seas. And then there's width. Catamarans are wide. And while that gives them all the extra deck space for cars, cargo, or passengers, many locks and canals were designed with narrower vessels in mind. It restricts where they can operate, and maritime industry is certainly not going to rebuild all the infrastructure around the world just for this new ship design. Finally, there's payload. When it comes to carrying very heavy cargo, monohulls still have the upper hand. Since catamarans are typically more expensive to build than comparable monohulls, two hulls, two propulsion systems, more complex structure, it all adds up. For operators, that premium only makes sense when the speed and passenger comfort can justify the investment. You also don't see giant container ship catamarans, and there's a reason. As you scale up, that structural weight penalty grows faster than payload capacity. The connecting structure has to span ever wider gaps and handle exponentially larger loads. For really large vessels carrying dense cargo, the economics favour traditional monohulls, so you'll most often find them on fast ferries where speed and passenger comfort are key. The wide platform means more seating and smoother rides, making them ideal for short, high-frequency routes. The US Navy's Independence-class littoral combat ships are catamarans, chosen specifically for their speed and ability to operate in shallow waters. And of course, yachts and leisure craft. The appeal's clear: broad decks for lounging, shallow draft for sneaking into hidden coves, and a smoother ride. There's also the Trimaran, one main hull with two smaller outriggings. One could say it's the cousin of the catamaran that blends some of the benefits of twin and single hulls, but that's a topic for another day. So, do twin hulls make ships better? Not exactly. Catamarans aren't trying to replace monohulls, they're just solving different problems. Every episode on this channel takes days to produce, from research and scripting to storyboarding, animation, and even voiceover, and it's all made possible by our Patreon crew. We've just revamped our Patreon and we've prepared a lot more to share with you. As a deckhand, you'll get early ad-free access to new videos, be able to vote on upcoming video topics, grab exclusive wallpapers for your phone and PC, and see your name on our supporters wall at the end of every new video. If you'd like a closer look behind the scenes, the officer tier gives you time lapses of our team working hard on brand new animations or thumbnails. You'll also get behind the scenes updates, animatic releases, and a monthly newsletter filled with maritime stories and news that we don't cover on the channel. And for those who really want to take the helm, our Captain tier lets you sail your very own custom-designed ship in the casual navigation art style, featured in a future episode for everyone to see. You'll also get your name in the end credits as a Captain supporter, with video shoutouts and private Q&A sessions on Discord. However you choose to support, or even if you're just here watching, it truly means a lot. You'll find the Patreon link down below. Thank you for keeping casual navigation afloat.